So it is this nature, it is this beauty of science, and here especially physics, that with the passage of time, as we collect the data through different experimentation, through different observations, we can replace earlier theory which doesn't fit the data, and it can be replaced by some new which is well known, which is qualifying, which is I can say which fits the data which has been collected, and that theory replaces the older one. This is the beauty of the science. Now another example can be taken, which is specifically regarding to physics. Say here, first, earlier you might be well known about it that earlier it was suggested that in Newtonian mechanics, which was suggested by Newtonian mechanics, that is Newton's theory of universe, Newton's theory of universe. This is what there is, and this is the final thing. They believe that this is the final theory, which is also known as the classical theory or classical mechanics. They believed that this was the ultimate theory, this was the grand theory which describes all the things inside the universe. But as the time passed, with the passage of time, different observations, different experimentations were done, and it was observed that this Newtonian mechanics is no longer valid. For example, when the discovery of atoms took place, molecules took place, even the smaller ones like electrons, protons, and other stuff like nucleus, etc. Classical mechanics suggested that few things about these very these particles, but the experimental data which was collected from this doesn't fit the data, or doesn't fit the theory which was given by Newtonian mechanics. So there was a need that this must be replaced by some other theory which must be describing all the experimental data, which must fit, which must suggest what is going on, what is the mechanism behind all these phenomena which are observed in these kind of particles, which are minute, tiny, small, or microscopic. So some theory must be there, some new theory which must describe the different phenomena which are taking place inside these particle systems. So this Newtonian mechanics, also needed some advancement. This also needed some replacement, modification. So this theory, Newtonian mechanics, was further then replaced or modified. We can say that is to be replaced because Newtonian mechanics doesn't fit inside the world or inside the domain of these particles, this microscopic world. So it was replaced by some another mechanics which is known as the quantum mechanics. Quantum mechanics is that very subject, that very field which deals with the microscopic world, I will deal with this concept in a bit later. Microscopic world. So the thing I am here going to say is that there are theories given in this field of physics or in the field of science, but with the passage of time, as we collect the different data from different eras, as time passes, there is a need of modification in the older theory, and that must be replaced by some new theory. Like in case of here, we need to replace Newtonian mechanics by quantum mechanics. Further, quantum mechanics doesn't describe the things which are moving with faster speeds, the things faster velocities. So this also needs to be replaced by some other theory that is known as the relativistic quantum mechanics. So there was needed another theory which would describe the faster moving particles, like the speed of light or approaching the speed of light. So for example, any particle is moving with the speed nearly speed of light, say c. When we observe these particles under the theory of quantum mechanics only, the experimental data was totally mismatching. So this quantum mechanics need a modification. It need to be modified. By what? By relativistic quantum mechanics, which deals with the faster moving particles, faster moving coordinate system, whatever that is, faster moving speed, faster moving some particles. If we want to study those systems, we need to replace quantum mechanics by relativistic quantum mechanics. So this is all. After that, the bigger ones are dealt in this system or in this field. For example, we have to deal with the bigger system like galaxies, galaxies, which are huge masses. So there we need some other theory, because relativistic quantum mechanics or quantum mechanics, this is only dealing with the microscopic world. So it will not fit into the bigger world, that is macroscopic world. So for that we need some another mechanics, some another theory which will be dealt with, which will be dealing with these huge masses. So for that we need another theory, like Einstein proposed theories. Other people like Hawking suggested few theories. So for that I can see like Einstein, he is well known, renowned. I will just for mentioning here the general relativity suggested by Einstein. So general theory came into being to deal with the microscopic world, the masses which are of huge bulk matter masses like stars, galaxies. So the thing I want to clarify here is that, which I earlier told you, that physics or in general science, there is a beauty in it, that every theory which needs to be modified, which needs to be replaced, is replaced by some new which fits the data, like I gave the example of this. So this is the beauty of physics, this is the beauty of science.